Коллеги, добрый день. Я Михаил Сафонов, руководитель Центра обучения управлению комплексными проектами «Сафонов и партнеры». Вот это интервью, оно немножко необычное. Необычное, потому что, во-первых, я взял у эксперта западного, взял его на английском языке. И, кроме того, мы затронули немножко тему такую слабо освещенную. Это управление информационным моделированием объектов недвижимости на фазе строительства. Я общался с Томом Денджинсом, собственником компании Synchro, и мы достаточно подробно обсудили вообще, что меняется в стройке, когда начинают применять технологии информационного моделирования, как меняется отношение стейкхолдеров к тому, что вы можете не только видеть эти колбаски-ганты, но вы можете их видеть привязку к модели, и что происходит, да, какие изменения. Соответственно, подписывайтесь на канал, будет много полезной информации. Да, кстати, хотел сказать, что интервью само на английском, но в ближайшее время должны появиться субтитры. Надеюсь, к тому моменту, как вы будете смотреть, они уже будут. А сейчас встречайте, Том Денджинс рассказывает о фазе строительства и применении специальных инструментов, которые используются в информационном моделировании объектов недвижимости.
All right, well, thanks for having me. I have a few slides, a short set of slides to take us through this. Is that okay?
Yes, there is no problem. What is interesting for you? This is the most important. If it's interesting for you, it will be interesting for the audience.
Okay, all right. Well, the first interesting thing is that I picked a photograph of a project that is cold. It's 40 below zero, and it'll remind you of what winter is coming.
So where is it?
This is in the Barrens of Canada, in a province of Canada called Manitoba. This is their power generation authority called Manitoba Hydroelectric. And this project is a brand new hydro dam. So it's a very low profile. So the whole territory, as you can see, has no mountains. It essentially is frozen or thawed, and during the thawed season, they generate power from the water flows.
And they have 4D schedule with Synchro, yes?
Yes, they do. They use Synchro every day on this project. It's a massive site of many square kilometers, and they're planning and scheduling and controls are being done through Synchro. As a means of this particular company who works globally. It's an American-based company, but they work globally, including Russia.
All around the world, yes.
They are around the world. And this is an effort by this company to adopt Synchro across every project on every continent in the world.
And before they work with Primavera or with something?
They did. In fact, the Primavera system in their company architecture is holding a position in the back, right up against their accounting system. So they have their accounting system in the far back of the organization, accounting for financial transactions, assets, otherwise project-oriented views on their work, and then right in front of the accounting system is Primavera, which collects the portfolio of project activity. Out on the project itself is Synchro. So Synchro is on the front lines every day. And then behind it, in the corporate information architecture, is Primavera.
So while, as I understand, they synchronize Synchro with Primavera and then work with all these documents. Okay.
That's right. 5 years ago, they would have had Primavera on the front lines on the project, and they see where virtual design and construction through Synchro has provided them significant positive impact on delivering construction projects.
Okay.
And the reason why is we'll go through this. We'll go through this presentation.
Okay, great. Because I have this question in my mind, and I want to ask you why they decided to go from Primavera to Synchro. So.
Yeah, and Primavera, from a scientific standpoint and a mathematical calculator for the calendar-oriented, task-oriented critical path method, is very solid. It's great science. But the difficulty in construction planning and scheduling is it's only part science relative to keeping track of things in a logical mathematical network. But when you are trying to envision the problems of construction, they're all space, time.
Yes. Location and space and time. Yes.
Yes. And we now live in a complex project culture is the message. And while it would be 20 years ago that this organization that we'll keep the name out for this presentation, this organization was working on some of the more complex projects all over the world among 20 or 30 other engineering construction organizations. A complex project of multiple billions of dollars was not common. It was extraordinary. Mm-hmm. Now, they would have these extraordinary projects go on for many years. The common project was a single project of hundreds of millions of dollars, not several billion. Today, the common project in this organization is a several billion-dollar project of significant complexity. And because of that, the space-time problems of construction become overwhelming.
So I have a question. Could I say that if we have some simple construction project, we don't need to use any 4D methodology? So we can do this with simple CPM method.
It is an attribute of where our experience in a simple CPM method will serve our interest. Mm-hmm. And that is where complexity, which is a relative statement, complexity is relative. Mm-hmm. So if I've done something 10 times or 1,000 times, it's no longer complex to me. It is routine.
Yes.
So if you're in a construction company where your works are routine, then absolutely we have the support of the science of CPM to organize our own innate abilities to see space and time through the drawings, through the routine of the project. But when it becomes the first time you've done a small project mm-hmm. in a tight location, in a city with challenging logistics, these space-time problems, even in a small project, become problematic very fast. And the sensitivity of the economics of a small project can be quite large. You know, I do a $1 million project and I have $1 million problem. That's catastrophic. If I have a $100 million project with $1 million problem, it's within the realm of the error handling of contingency. Mm-hmm. So it's all relative, Mikhail. And you know, where you see complexity may be in a 2-week period of time on a project, and the 4D system helps you understand the complexities as a problem-solving environment.
But so if I want to use it, I've got to have some information model before designed, because without this model, it's impossible to use Synchro, I would say. Yes?
Without the 3D models,
yes.
The use of Synchro becomes redundant to using Primavera.
It's like a scheduler, nothing else. Yes, simple.
Exactly. When I say redundant, it is the exact same science and methodology as Primavera without the 3D model. So absolutely, you will seek to either reuse a design model or create your own. And creating 3D models from construction documents is quite fast. It takes hours of time, mm-hmm. not weeks of time or months of time. And the reason for that is when you're in a design environment using 3D, The 3D is a output of your design thinking. Design is slow. Design is patient. Design is creative. When you're modeling for construction, you have the input of the design that's already completed. And now you're just transforming 2D documents into 3D, and it's very fast. There are tools for this, and that becomes the input for Synchro.
Yes, yes.
So where design exists in 3D, it's a direct import into Synchro, and I'll show you some examples of that. But where you lack 3D, you do not need a 3D design model to use Synchro. What you need is a 3D construction model to use Synchro.
Yes, and as I know, it's possible to download for free the scheduler, and then if people want, they can for money, because to upgrade it to 4D. Yes.
That's correct. Our scheduler application is a free application, $0, no tricks, no hidden fees. It's the equivalent of Primavera P6, and its ability to manage the science of CPM is quite robust and advanced. And we believe that's the right price for such a system that has all of its value in its space-time capabilities, which is 4D, and that's where we charge a license fee.
Okay, okay. So let's go further, I think. Yes.
All right. So with its complex culture, let me just walk you through an example. This is an airport in South America. You could probably tell where it is by the airline flags that are in this photo. But essentially, the country and this city airport has asked the construction industry for a 20-year agreement that says design and build and operate our airport for the next 20 years. So design and upgrade, this is the airport site, so it's quite large. And although it does not include the runways, because it's just outside the runways or just inside the runways, it's a $1 billion project. It's quite complex, and you can see the areas by their description, and then it's a map view. So then we narrow down, and we can see this area of, and I just gave it a larger scale.
Inside the square, yes.
Inside the square, and in the middle of the square, you see the area T2M, which is the terminal, which is this location here. So it's quite a complex project. It's large. It's a large area, and it's in the interest of the contractor, the construction company. And it's both a French and Italian joint venture that's working on this project to design and engineer it well and to construct it economically, because they're under a concession to operate it based on landing fees and operating fees for the next 20 years. And when you look at this design, it's quite obvious that this is a 3D model, and they used a CAD system. So this comes into existence from the minds of the architects and engineers through a 3D model, and it is one model.
Yes, yes.
When they printed the drawings for construction,
there's documentation for this project, as I see, yes.
That's right. The documentation just for design output were found in these boxes. So if you look, these boxes here, all the way down this corridor, hold one set of drawings.
So I would say it's impossible to use it. All of them.
Well, you'd need an awful lot of time. And if you can imagine, you're the guy over here at your desk with your set of drawings in boxes over here, and you unpack them and you roll them out on your desk, and you start typing into Primavera or even Microsoft Project or Synchro Scheduler. It is an impossible task. And then you go even further and you try to review your your intellect and your approach to the project by typing into the system and then print it out and review it with your colleagues, it becomes even more complex and more misunderstood, if not completely riddled with problems.
And that's why we have some picture in Primavera and completely another picture on the construction side. I think this is the cause of that.
Yes, and to the extent that Primavera and our minds cannot grasp the complexities of space and time,
yes.
The site does. When you're working out at a job site, it is obvious, it is underneath your feet, it
yes,
is before
yes.
your eyes, and we sort out these spatial conflicts every day on the spot. Now, we all know what that means: reacting, not planning, not controlling, but reacting. And it's chaos. As much as we try to make it organized, construction projects are largely organized chaos. And this is where productivity, this is where certainty falls apart.
Is it possible to say that in Synchro and for the methodology we connect the project model and object model? We connect I would say, point of view of engineers and point of view of managers to manage it.
Correct. And the managers have a creative layer, which is the approach to the project. Do I go left or right? Do I start in the middle and go up? How you approach a project is very strategic, and it's situational based on the design, the time. If you started a project in June, it would be different if you started the same project in Moscow
in February, for example. Yes.
Or February, yeah. So what I'm showing you here is that these boxes today with Synchro are not opened. They're there for reference.
They are not printed.
Well, they are printed, yes. And God save the trees. But the point is that now these models come directly into Synchro, and Synchro orchestrates the software engineering orchestrates the planning process through a visual environment where you have one model from design in one model in your project planning, and you are able to see in fine detail where in the project activities are going on, when they are going on, at the rate of production that you're planning, as well as tracking through the controls process. So this is the new paradigm of construction, planning, scheduling, and controls. It's now a new visual environment. And as you will see on this screen, it holds all of the data,
yes,
all of attributes of the design, all in one referenceable model, as well as what we are all used to, which is the logical diagram of the schedule. So this is how we tame complexity today. This is how we support decisions. Is it left to right or is it right to left? That's a decision. And how do you know what is best for your project? Well, you get more thinking, you get more analysis behind the ideas in an objective, constructive way to support the decision.
So how many people do we need to schedule such a complex project? How many schedulers?
Well, let me give you a case study that's happening right now. Under traditional planning methods on a project at the Los Angeles International Airport, which is a portion of the airport today under construction, which is the expansion of the international terminal to satellite terminals, where you have a tunnel under the, if you will, the ground of the airport, and then you have another building that's a satellite for more gates. Well, Los Angeles International Airport is expanding their international terminal, and the satellite is a $2+ billion project. Under traditional means, there are 5 planning specialists who are in 5 licenses of Primavera. This is the traditional staff, and it becomes a very difficult job to take on.
Yes,
Today,
to synchronize all that and to yes, it's very good.
and to print things out and to have your hand-waving meetings where you're trying to point to something in the design and the site map and then the plan in the Gantt chart, and you're trying to orchestrate this understanding from your audience. Today, there's one person on the project, not five, one person on the project operating and responsible for being the synchro user.
Mm-hmm.
Now, there are many more people engaged in the process of working with synchro. And later on, I'll show you some photos. But every day, the foreman, the project managers, the superintendents, the client, the organization that's all engaged, the stakeholders, every day, not every person every day, but these groups and these categories of people are in the job site office working with the synchro specialist every day just to understand the project virtually every day, so that they're always in this planning mode, even with progress reporting and tracking of the project controls process. That data comes back to the synchro model every day, all day long, giving people insights into what the gaps are, either growing or shrinking, between what is planned production and actual production. And while one person is responsible for this software interface and synchronizing all of this data and all of this interaction, you end up with more people engaged in the plan than you would ever have in the past. So in the past, you'd have 5 people all day working and sweating over these plans that no one ever really paid attention to. They consumed information from it, but they never got engaged with trying to understand it.
So that means that you can involve more stakeholders, yes, during the project. And
correct. And their understanding of what's happening or what is planned to happen is instant because it's visual.
So, do they have to change their processes, inner processes in the organization to work with Synchro? And how long time it takes to go from Primavera to Synchro to start to work with it?
Now, the subtleties are a long time, but the bulk of the processes that we already have, the traditions, are all the same. There is a project design, there is a plan, there is an approach to construction, and then there's a CPM. So it's the exact same science. You have some understanding and some learning for how to control the CAD information, but that's relatively fast. So within a few days, a traditional planner can introduce themselves and become familiar as a user within a few days. Now, the subtleties of an organizational process map take a long time. There's no doubt about it that an organization, a shift from traditional planning methodologies to a new environment where this impact on all these participants start to begin to happen. You're now starting to create processes and meetings that you've never had in the past. You've never had these types of interactions in the past because it was useless. Today, these interactions with the model are quite useful. So it does take time to understand how to organize the project delivery team around interacting in these work sessions where in the past they never did. So that adds new interaction that needs to be sorted out. And that's, quite frankly, organizational. You know, one company may decide to do it one direction because of its environment and its level of complexity or routine, and others do it another way.
Yeah, it's a new way of working, I would say so, yes.
It is a new way of working. So, for instance, we had a project team in England, and they were doing a drinking water processing upgrade for what is a pH treatment on the water. So they would test the water coming in for pH. They would treat it with a lime technology, a lime-based chemical engineering technology. And then the output would be a pH that's within European regulations. So it was a small project. It was about 50 million pounds sterling for this project. And they had a choice of how they would deliver the project. And the choice was A, traditional, ship all the pipe and the pumps and all this equipment and parts to the project in a live water treatment facility, or B, prefabricate packages.
And then this package is delivered to the construction site, yes?
Right. So just by example, package number 5 was in the project plan for 6 weeks on site in traditional methods. Plan B was to prefabricate a module called package 5. And it was 3 days on site for hookup. Now, there's no question that there was labor hours in the factory that pre-assembled the module, loaded it on a truck. The truck transported it to the job site. The job site now has a much larger rigging problem in that it's not a bunch of loose pipe. It's now an entire assembly of say, 10 meters by 4 meters of pipe rack, pumps, hangers, stairways, work platforms, all of it put together in a factory, put on a truck and brought to the job site. So it's a different problem. So at the job site, instead of a planner sitting there trying to figure out the order to which these pipes were going to come together, or the area for 6 weeks for this crew to assemble this section of the plant, they now have to run workshops to design what will be the module. So they didn't design the size of the pipes. That was all done in what they call the placeholder model. Now they do design for what parts are in the module and what parts are not in the module. That takes a workshop of engineers, of construction engineers, to make those decisions on what's in the package. So the design of the package gets done now. Now it's a function of designing it within the tolerance of transport, certain size, certain weight. And now you move to assembly and rigging. So you have work session, step by step through the process, and these work sessions create a different working conversation than you would if you simply did a spatial coordination on detailed design, ship the parts to the job site, and put 15 skilled mechanics to assemble it all for 6 weeks. So this shift in methodology, in Britain, they called it digital rehearsal.
Yes, digital rehearsal. They can think beforehand about different strategies. Yes, how
correct.
To deliver that.
And they did several. Well, what if this was included and this was removed? Or what if we cut here and we put in mechanical fasteners for what we cut in, say, a staircase or a work platform or a handrail. So they had to think through in these workshops in what-if scenarios. Or what if we just left this out and we assembled it later as a whole piece instead of 2 half pieces? These digital rehearsal sessions were very exciting. People were very enthusiastic. They were cooperative. There was no fighting going on because they could see their ideas manifest before their eyes through the model and through the planning process, because it's still the same planning data and the same planning thought process. It's just that the technology was able to virtualize it quickly, and everyone could understand and see issues instantly. So they worked through these digital rehearsal sessions right up to the last session was done in the factory, so that the factory foreman and its mechanics in the factory where this was being assembled could rig the unit not just for load but for offload. They could stack and palletize the connection pieces in the order that they would be installed in the job site as a last connection detail.
Okay.
And then, of course, when they got out to the job site, it was 3 days of calm with far fewer people on the job site in a neat and clean environment without a lot of banging going on with parts and being assembled over a 6-week period.
Yes, yes.
And it was one truck through the gate, not 50 trucks through the gate. So the logistics were far different. And the economics where they saved over 50% labor hours, and which was the assembly process. And if I could share with you on that one package, they put $50,000 to the bottom line because they were hired on traditional costs, but they engineered a non-traditional approach. And all of those sessions, all of those meetings proved to be a profitable enterprise.
Okay, great. So let's go further. Yes.
So all of this has a history, and essentially what you've asked already, which is what's going on here, and essentially for many thousands of years, we as builders have been given drawings with symbols and lines on paper, the modern paper, so that we can imagine the design in our own spatial mind, our own mind with our own ability to imagine spaces, and we separately plan through the process. But with the advent of 3D design and the spatial capabilities of our computer-aided design systems, and they date back many decades, but those many decades of design have been largely used in mechanical industries like the aerospace or the mechanical, the heavy industries have used 3D models for many decades. But construction, with the exception of what was happening in the oil and gas industry, which is a heavy manufacturing front end, with the exception of what was happening in oil and gas, the construction industry, the engineering and construction industry around the world has been largely 2D, not 3D CAD systems. But in the last decade plus, the CAD systems of design have given us 3D models, and with our software, we simply combined the science of planning, scheduling, and controls with the science of computer-aided design, so we could bring them together in what is 4D, which is space-time. And that gives rise to a whole new methodology and practice of virtual design and construction. And this is the culmination. So this is the historic journey that's taken us to where we are today. And it's aided by our software that we've created to bring and synchronize these processes and this data into one environment for us to virtualize for planning and scheduling and controls processes, an environment that's visual, insightful, easy for every stakeholder to participate and understand.
Okay. So okay, yes.
So to synchronize these processes, it's best to start with a goal. What's your objective? And many companies will start with the question, what does it do for me? What what is the expectation? Why would I do this?
To build cheaper, faster, with best quality, I would say, so to satisfy.
So what? Yeah, exactly. So the industry starts in a position that is very detrimental to their own benefit. If everyone starts with, well, what are you going to do for me? Instead of, what do you want to do for yourself? If the company starts with the question, what can I do for myself? The process of adopting synchro and 4D and virtual design construction practices are so much faster than to sit back and ask the question of a software company, what are you going to do for me? No. What are you going to do for yourself? What do you want to solve as a company? And what I've shown you here are 4 statements which were made by our customer on why they bought Synchro.
Mm-hmm.
Not my reasons for buying Synchro, but their reasons for buying Synchro. And this was the first instance, not after the fact, not after experimentation, not after trying to figure out what does this thing do. No, they have a construction operations, and one of the companies they set out to reduce project delivery time by 1 week in every 6 weeks of a project. Now, 1 in 6 is quite substantial in terms of time on a site over traditional practices. That's what they set out to do. And when they tried to do it, their best and most effective, in fact, the only way they could figure out how to actually affect speed in their typical project delivery was using Synchro.
Mm-hmm.
So they set out to do something, and they learned how effective Synchro in their processes to affect faster construction. So in a 2-year project, which is not an uncommon length of time for a construction project, they were able to save 4 months.
That's enough, yes.
That's real money, and that's real fundamental change in the conditions of the construction project that affect the economics. So for them, that was $1 million just on one attribute, which was the cost of the money during construction on an average project of $50 million. So the cost of interest to the bankers during construction was reduced by $1 million. And Synchro saved them money on their operating costs because you need less people to use Synchro. So their operating costs went down. They did not measure that. Their construction problems went way down. They did not measure any of that. On the interest charge alone on construction money, the construction loan, was enough for them to look for ways to cut time. And they settled on Synchro because it was the most effective system out there. The second one was achieve 70% off-site prefabrication.
Mm-hmm.
That was the example I gave you on package
Yes,
5.
with packages with that, yes.
And they absolutely started with the objective of removing 70% of the on-site work to prefabrication. That was their goal. They had no idea how to do it. In fact, they thought it was impossible. They achieved it with Synchro.
Mm-hmm. When they made the model, I would say so, yes, of this project.
That's correct. And there was no doubt that they had an investment in the model. But the investment in the package 5 model was £5,000. Their savings on staff for scheduling saved over that same time period probably £4,000 or £5,000. So the investment to create the 3D model was not more expensive than it was to shift some of the processes. And then we have the simple statement for what was a nuclear facility and their outages, their major contract outages. They wanted safely home every day, every person. And they achieved that for the first time through what was a derivative benefit of practice. Mm-hmm. Instead of having foreman's meeting once, which they would go through the project schedule over a 30-day outage with over 1,000 activities that people would mainly be daydreaming because they didn't understand any of this project plan on a Gantt chart. They turned it into several, over 20 meetings with the foreman on the foreman's demand that they keep practicing through the digital model, because they had the first meeting, which was regulatory, and then they had such a great time and a great impact on their understanding of the job that they wanted to do another one. They ended after the 20th practice session before the outage went forward. And in the year prior, under the same outage conditions where they were replacing a stator, they were replacing the generator for a particular turbine. This was the second generator they were replacing 1 year later with a brand new generator. And in the prior year, their 30-day outage went to 67 days. Problem after problem after problem, day after day after day of responding and reacting to spatial issues because these are power plants. It's tight spaces, and there's lots and lots of piping and feeder and electrical, and you name it, it's in there, and you can't simply throw more people at the problem because you have this workspace coordination to go on. 67 days. In this year, after all these practices, they were 3 hours early on the outage, fully tested, fully commissioned, and online 3 hours early with the exact same scope of work, the exact same crews, the exact same methodologies of how this would be replaced. But because they had 20 sessions of practice, they were able to get this job done. But most importantly, when you're in a nuclear facility, any incident, accident, or near miss is a recordable investigation. And that in and of itself causes delays within the construction operations. Because if it's a near miss, if it's a dropped tool or a dropped part, that has to be investigated on why it wasn't tied off or wasn't protected in the first place. So these kinds of situations went from nearly 20 the year before to 0 in this particular project a year later, using Synchro as the practice environment. Mm-hmm. And then lastly, a Brazilian company on an oil and gas facility basically used traditional methods, but because they had a 4D model utilizing spool level, piece mark level planning, they were able to produce 4D drawings every day for their foreman, who could explain every pipe that needed to be installed with their mechanics on this site. And just utilizing better communications, better cartoons in a 4D context, which were just a straight output from your plan. Every day they would track what was done, inform what is to be done on the next day. They'd print them out, give them to the foreman would review them with his mechanics in this complex site, and they were able to achieve 75% labor productivity increase. That's a big number. And not change any of the methods, just give them a better communications. So the function of synchronizing process, data, together in a virtual environment is what's making the impact. Synchro has a platform. It's a complex environment of software and technologies and practices throughout the life cycle of a project, including how we manage multiple users on the same model. And each one of these is a example of the system in its in a video, and I won't go through that with you. Just to simplify our time today.
Okay. So just to understand how it works. So in general.
Yeah. So you have site, which is an on-site data distribution and collection. So you can see the model through the iPad, and you can use the iPad to collect field data. Mm-hmm. Pro is the application for planning, scheduling, and controls. It is the interface for the project scheduler. Then you have Scheduler, which is the free application, which is just CPM, traditional. You have the Open Viewer, the OVR. That's a free application, so you could take the 4D model and review it without license. So you just need access to the model itself. We have a professional services team. We have a call center, a support for our technology users. And earlier I mentioned that I could show you a photograph of the Los Angeles airport.
Yes.
This photograph right here. This is the synchro specialist. He's in a workshop, a workroom environment, and foremen come in every day looking for an interactive session with the model, sitting with the specialist so they understand what's coming, what's going on, what the issues are. And in this particular case, you see two foremen coming together talking about how they're going to coordinate across two different operations in the same area.